Right, it's recording. I'm going to start now.
The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Thank you for joining us this afternoon for MindStream Analytics and spending a little bit of time on your Friday. My name is Del Rogers with MindStream Analytics, and today we'll be presenting on Predictive Analytics Demystified. Before we start, just a couple of housekeeping items, if I may. To confirm that you can hear me, that everyone on the call today can hear me, please see the button on your screen that says raise your hand, and that way they'll let me know that everyone can hear us without any problem. Great, thank you. On the right side of the screen, you will see a question tab. At any time during our webinar, please enter any questions you may have in the question box, and we will address all questions at the end of the webinar. Now let me give you a quick overview of MindStream Analytics, if I could. MindStream Analytics was selected as one of CIO Review's 20 most promising data analytics consulting company. One of our customers, Windstream, was recently awarded the 2014 Performa Tech Award for Excellence for the most effective adoption of technology by a financial organization. This award recognized the value created by MindStream in guiding Windstream to the highest level of performance in risk management, cost reduction, and operational efficiencies. According to recent statistics from IDC, you're seeing a transformative shift in data. Cloud and customer engagement is making CFOs, CMOs, and other C-level executives more buyers of technology. What MindStream does is help guide executives in technology areas that they may not be familiar with, integrating data from different sources and extracting value from it. Our certified skills and trusted advisor approach provide a reality checklist, if you will, for our customers leveraging our analytic technology partners like IBM to reduce our customers' risk while providing highest level of value, award-winning services, and take a direct line to the bottom line values. I'd like to introduce to you our presenter today, Quan Tin of MindStream Analytics. Quan is a business intelligence professional who has worked with many DRM, HFM, and planning implementations. His consulting at MindStream Analytics, a Boston-based consulting firm and managed services firm specializing in enterprise performance management and BI analytics solutions for our customers. Quan has 5 years of experience with EPM software products and 7 years with business modeling solutions. Prior to joining MindStream, he worked at IBM, PwC, where he offered advice to clients on business strategies and business process optimization. Quan, thank you for being with us today and continuing our series on Predictive Analytics Demystified. I will turn it to you and let you take it from here. Thank you, Quan.
Thank you, Del. Good afternoon, everyone. My name is Quan Nguyen Tien. I'm happy to be here today to present and continue on our series of predictive analytics and big data. In our last webinar, we went through the definition of what predictive analytics is. It basically helps firms better understand and predict customer behavior. We talked about the goals of predictive analytics, and among the most important, we mentioned that it brings key business insights into our decision-making processes and creates positive return on investment. And there are also 4 areas that the companies should focus on to leverage predictive analytics. The first areas that we mentioned were customer analytics. To help do that, organizations are using customer analytics for advanced client segmentation so they can market the customers as individuals. They're analyzing the social media sphere as well as other unstructured data to gain and improve understanding of customer sentiment, to take actions that improve customer loyalty and decrease customer churn. The second area is transforming financial processes. Organizations are focused on enabling rolling plans, improving their forecasting and budgeting processes, and responding to changing market dynamics. The third we mentioned was risk-aware decisions, and finally the fourth area of operational efficiency. Organizations are using analytics to drive the next wave of operational efficiencies by optimizing their supply chain, identifying threats, and reducing fraud, especially in banks. And most recently in the emerging area of predictive maintenance, which is using analytics to predict when maintenance is needed so that it can be done before the failure, not after. Today, we're going to dive deeper into the process of building predictive models. I'll show you how we can create simple models, and we'll try to show that on some sample data that we collected, and we'll try to analyze and show the results that we got to. The first thing I would like to define is the CRISP-DM. The CRISP-DM is the abbreviation for Cross-Industry Standard Process for Data Mining. It includes 6 phases that address the main issues in data mining. The 6 phases fit together in a cyclical process that you can see on the screen, and it's designed to incorporate data mining into your larger business practices. So the first phase is business understanding. This is perhaps the most important phase of data mining. Business understanding includes determining business objectives, assessing the situation, determining data mining goals, and producing some sort of project plan. Data understanding, data provides the raw materials of data mining. This phase addresses the need to understand what your data resources are and the characteristics of those resources. It includes collecting initial data, describing data, exploring data, and verifying data quality. The third phase is data preparation. After cataloging your data resources, you will need to prepare your data for mining. Preparations include selecting, cleaning, integrating, and formatting the data. That can be all done in one tool. Modeling, well, this is, of course, the flashy part of data mining, where sophisticated analysis methods are used to extract information from the data. This phase involves selecting modeling techniques, generating test designs, and building and assessing models. The last two, evaluation and deployment. Evaluation includes how data mining results can help you achieve your business objectives. Elements of this phase include evaluating results, reviewing the data mining processes, and determining the next steps. And the last phase, deployment. Now that you have invested all of this effort, it is time basically to reap the benefit. This phase focuses on integrating your new knowledge into your everyday business processes. So today we're going to demonstrate some modeling on IBM SPSS Modeler. Why IBM SPSS Modeler? IBM SPSS Modeler is a complete advanced analytics workbench. It includes functionality in the three major phases of your project, right? Data preparation, modeling, deployment. It's very user-friendly and easy to use. It utilizes both structured and unstructured data and enables positive returns on investment. In SPSS Modeler, there are modules that can basically access all the data, structured or unstructured. And there's also a natural language processing that extract concepts and sentiments into text. Modeler is very compatible with all the systems. Analysts can have direct access to multiple sources of data, and they can merge, rearrange, and augment their data on their own. Data manipulation in Modeler can be learned in a matter of days, even by analysts without a lot of experience with ETL tools. Modeler has dozens of advanced algorithms for finding patterns in your data. It has algorithms that help you narrow your search, and these modeling techniques are quite powerful. They basically multiply the analyst's effort getting you to your destination faster. Even a novice can provide the value to the organization using the SPSS Modeler. And the compatibility, as we talked about it before, it has many ways how to collect the data and connect to other products such as IBM SPSS Decision Management or IBM Collaboration, where you can deploy your business and decision strategies. So let's go into our demonstration. We downloaded the public data that have been collected monthly via customer interviews held at all airport terminals at San Francisco International Airport from July 2005 through March 2011. Interviews were done using random sampling, and the questionnaires were available in many languages, including English, Japanese, Chinese, and Spanish. Before we go into our data analysis, let's break down the phases that we need to work on with our data. First, we need to understand our data. We need to determine the fields that can be used as independent and dependent variables and the ones we can remove. The data can then be partitioned, where we can create the training data and then scoring data as well in order for us to basically confirm that our models are correct. And of course, the last one is scoring the model. We talked about it to make sure that the model is correct. We will compare all those partition data to leverage and train the model itself. So this is a screenshot of SPSS Modeler where you can see that the main screen contains, we call them nodes. And those nodes have each their own functionality. Either they read the data, or they merge the data, or they select and create some charts or graphs, or maybe regression. And some of the nodes can integrate with our downstream systems, such as the SQL database or other OLAP or IBM databases. When we read in the data, the first thing that we need to do is to clean. That's the part of data preparation, right? Every data that is collected has some outliers, has some missing values. And SPSS Modeler is very useful to handle these missing values and outliers. There are several ways how you can handle them. In our case, we decided to remove the outliers and handle the missing values by imputing the mean of the data. This is, I think, the most common practice, but of course, it all depends on your understanding of your data, whether we should impute the mean, sometimes the median, or sometimes we would decide just to remove even the records with the missing values. Part of the first phase is data understanding. So we try to analyze our data and create segments, passengers by origin or destination. And we could easily see that the most is from US or Asia. We try to segment our passengers by airlines that they've been traveling with. And it looks like in San Francisco, the home airlines are United Airlines, followed by American Airlines, and to understand better our passengers, we created a simple cross-tabulation of destinations and incomes of the passengers to see how they are correlated. In this screen, you can see that selecting the crosstabs are very simple, and anyone can do that. It's very user-friendly, and it helps us to understand our data better. So from now on, we try to analyze our data based on origins, based on incomes, based on airlines, and we narrowed down our factors that should somehow affect our main predictor. We decided to analyze our data based on whether the passengers are choosing the first class or business class, whether they're buying the first class or business class, or they're buying the economy class. So in order to do that, we created a new variable. We can call that variable a business class. And this variable basically tells us whether the passenger bought a ticket with a first or business class or not. It's a Boolean variable, which means it has only two values, 1 and 0. 1 meaning the person bought, 0 meaning didn't buy the business or first class. So based on this cross-tabulation, we should get the results where the first and business class should rely on the income on of the passengers. We created a model, and we had our target field as our business class variable, and our input fields were income, length of a flight, type of airline, age, and gender. Those were the 5 independent variables, or the factors that affect whether the passenger buys or doesn't buy the business class. SPSS Modeler ran the model and ran the regression, and we found out that the income and the length of the flight is basically the most significant variables that affect whether the passenger buys or does not buy business class ticket. And it's as expected, the higher the income or the lower, the higher the income or the higher the length of the flight actually creates incentives for the passenger to buy the business class ticket. On the screen, you can see that we separated our analysis into the top 3 models. The data were split into training, testing, and validation. And as can be seen, each of the 3 models have extremely high accuracy of percentages. For both training and testing data sets, we have higher than 95% accuracy. We now, of course, have the option of choosing 1, 2, or all 3 models to conduct the remainder of our evaluation. And if we choose more than 1 model, SPSS Modeler creates an ensemble model and provides those results to us. For the purposes of this exercise, we chose all 3, and it tells us that all the models are basically saying the same. In that case, we can go back to this crosstab and we can confirm our first assumption, and we can say that it is obvious that airlines should provide first class and business class on the top 8 routes, and on the remaining routes it is not necessary for San Francisco International Airport. So this was our model. And to give you kind of idea what other examples we have gone through or we have provided our clients, there has been a project with HCDE, and the challenges was to increase its high school graduation rate. We intervene and analyze 23,000 text-based surveys and other data, and after using predictive analytics, the teachers and administrators could now identify at-risk students, constructively intervene with personalized assistance, predict with intervention activities, and produce year-over-year improvement in behavior. We have 10% increase in graduation rate, 25 hours of cut off the workload of creating each report. Our next client was XO Communications, where we partnered with IBM in this solution. Telecommunications companies need to control somehow the churn, and the churn creates a bottleneck to their processes. So after the company, at the company we implemented the predictive analytics, customers are scored on the likelihood to churn per month. And through the BI web interface, client service managers access predictive data and customer profile based on territory and prioritize customer outreach. We have seen 376% return on investment, and average annual benefit for the company is $3 million. The last company that I wanted to show was Centerstone Research Institute, a healthcare company that wanted to ensure that patients actually receive the benefit of new breakthroughs. Patients received correct diagnosis and treatment less than 50% of the time. So this was a problem, and once we used predictive analytics, we were able to create the profiles of the patient and improve the efficiency, operating costs, and especially the patients were treated better and with higher accuracy. We have seen 42% improvement in patient outcomes and 58% anticipated reduction in cost per unit of outcome and change. Every year, Gartner assesses the market for BI platforms, and this year the industry analyst firm added more emphasis on predictive analytics to its criteria for evaluation. Gartner has acknowledged for the 4th straight year IBM and Oracle overall leadership for completeness of vision for BI and analytics platforms. In 2014, that leadership has grown, and both IBM and Oracle products are also top 5 in terms of the ability to execute, delivering values to customers today, as well as vision and leadership for the future. The analytics world, as we know, it is changing in real time. For many, we're moving from a world where many businesses, users passively view information about historic results delivered to them on a scheduled basis with a series of absolute measures with prospective operations inside the business. We're rapidly moving to also neat active discovery, real-time analysis, and dynamic predictive model, completely integrated across the business with measurement adjustment for potential risk. And finally, the analytics are consumed by many outside the enterprise, so outside in thinking needs to be accommodated. So no matter where we start or what we need to do, today's business climate is demanding comprehensive capabilities across a spectrum of different use cases. It's very important to include the analytics platforms in our industry, and that's why we are here, MindStream Analytics, and we're hoping that we could be of any help to all of our clients in order to implement the predictive analytics to their usual daily business processes. And that was also the last slide for me. And we're now looking for your questions, and we're hoping to answer many of your questions that you have.
Quan, thank you so very much for the presentation today. A couple of questions that have come in. Back on some of the earlier slides, I noticed that as you were going through it, started seeing statistics coming up, percentages, statistics of the customer. Is that something that you entered in from a customized process, or does that automatically generate from the data that you're entered in there?
Correct. So as I mentioned before, SPSS Modeler is fully integrated with other SPSS products such as SPSS data collection, SPSS decision management, and as well as SPSS statistics. So it's basically one of the modules of SPSS Modeler, and when we create our model and try to understand our data better, I myself use SPSS statistics module to create crosstabs or any other analysis that segments our data. So this is something that is very nicely done in SPSS Modeler, that it basically automatically opens up your SPSS statistics module for you in order to analyze your data better.
Okay, great. Thank you. One of the other questions that came in was, what systems can SPSS pull data from, or how easy is it to integrate with other systems?
So as we showed in our slides, could be SQL databases, it could be OLAP, it could be any IBM or Oracle databases, or it could even be an Excel file. So it's very easy to integrate other systems or databases, and in IBM SPSS Modeler, you even have those templates ready for you.
Okay, great. Question came in, and I hope I'm getting this correctly. It says, do you think predictive analytics is business or algorithm?
So, and I myself think that, or let me maybe clarify this question if I understood it correctly, whether we can use it, or whether business user can use the SPSS Modeler, or it is probably more related to coding and algorithms, if I understood well. So
I think you're correct with your thinking. If I'm not, they'll correct us with adding another question to it. But I think you're correct on that.
Yep. So I myself think that it can be both. As you can see from the screen, even a novice can run very sophisticated statistical analysis, such as regression, logistical regression, different charts and crosstabs, and using this tool, any business user can customize and create a model on his or her own. But it can get more and more sophisticated because IBM SPSS, as I said, is compatible with all other systems. It actually has the adapter that connects with R. R is a programming language, and it's an open source. And whoever can code and program in R can make SPSS Modeler a very, very powerful tool by adding his own algorithms and coding. So I think definitely both.
Okay, great. Thank you. Another question that came through. In building predictive models, is it possible to go back and make an adjustment to enhance the data? For instance, you were showing the airline and talking about first class, business class. Is it a fairly simple process to go back and do more of a deep dive, if you will, into some of that information? Quan, are you still with us?
Oh, I'm sorry, I was on mute. So let me show you on the model here on the screen, where you can see every single node on our screen are customizable. And it takes from our original data, and every node somehow corrects our data. But our original still stays the same. So when you have this full data model, you just need to push in your original data, and it will transform your data as it is. So there is, and actually developers in SPSS Modeler are using it a lot to go back, correct your data transformation, and just run the model again. And it can be run anytime and many times, and it definitely helps us to improve our model and enhance it. So that's also what the whole CRISP DM process is about, that we can really circle back to our previous phases, data preparation, and then run the model again.
Excellent. Thank you. Any other questions? Great questions so far. Appreciate those. Any other questions from anyone on the call today? All right, Quan, I want to thank you so much for presenting Predictive Analytics Demystified and the continuing the series. We will have you'll all be receiving information about this. As was indicated, this was recorded, and we'll be getting all that out to everyone, as well as be the follow-up to the last webinar in our series, which will be coming up in probably about 6 weeks. Thank you again, Juan, and thank everyone for attending, and I hope have a wonderful weekend. Thank you.
Thank you very much. Thank you, everyone.